Okay, good morning, everyone. We are going to continue from last time, which is on Monday, regarding the properties of exponents. Okay, so I wish you guys to have your paper pencil with you, and so we're going to continue on deriving. Okay, we're going to continue on deriving. All right, ready? Okay. All right. So last time we did, we understood and proved all of these properties. Okay. So let me make the fonts just a little bit larger so you can see the negative sign. There's a minus sign here. Okay. So I want to make sure you guys see those minus signs. Okay. So now let's continue. Okay, continue on that table, okay, with your paper, pencil, notes, okay, taking the notes. All right, the next row, okay, the next row is about b raised to the power of n. Okay, so b raised to the power of negative n, okay, minus n. Well, by the way, n itself is not necessarily positive or negative, okay? Be reminded of that. This is go by definition. B raised to the power of n is defined as 1 over b to the power of n. Okay, and the next one is b raised to the power of 0. What do you think this should be? B raised to the power of 0. Alan, what do you think this number should be? Provided that b is not 0. Okay, provided that b is not 0. So what should this number be? B raised to the power of 0, right? So this need to be answered. And the remaining two, I'm going to hold on. I'm going to wait a little. Okay. So what is the implication? For example, right? On the column A, we have b raised to the power of -2. And by this definition, it should be 1 over b squared. It should be 1 over b squared. So another way to write 1 over b squared. How about b raised to the power of -1? And that will be 1 over b, right? And more examples. Say, what is 1/2? Well, 1/2 can be written as 2 to the power of -1, and so on and so forth, right? So with this definition, we basically can write exponential form or fraction form with exponential form involved. Okay, for example, 1/4. 1/4 can be written as 4 raised to the power of -1. It can also be written as 2 raised to the power of -2. Right? You can see all of these for practical purposes. That we could do. And now, what value should be assigned to b to the power 0? Okay. So here's the reason. Here's the consideration, right? If we look at the situation to get a b to the power 0, right? We understand that b raised to the power of m divided by b raised to the power of n is equals to b raised to the power of m minus n, right? We're certain about that. However, what happens when m is the same as n? For example, m is the same as n, right? When m is the same as n. And this is still true, right? This is still true. When m is the same as n, right? So m is n, n is m. So this is m. So that turned to be m minus m. M minus m is what? It's b raised to the power of 0. Provided b is not 0. B cannot be 0 because the b is in the denominator, right? B cannot be 0. So that's how b is not equal to 0 must be satisfied. Okay? And now, b to the power m divided by b to the power m, that's equals to 1, isn't it? So it is only reasonable that we assign when b is not a 0, b to the power 0 equals to 1. So right here. Okay. So now let's look at column B. Let's look at column B. Let's look at column B. Okay, we understand all of these rules. Okay, so what I'm going to do is that I'm going to make these table a little more condensed, Okay, for example, I'm going to, let's review this part, right? So this is equals to a to the power of 8. So we keep that. And we're going to condense this by applying the formula, right? And we're going to condense that by applying the formula on the left. And over here, and for division, right? So we make these a little bit shorter. And b to the power negative n. And these examples, and I go, did you guys write it down? Did you guys write it down, all of these tables here? Okay, if you have, I'm going to make it just a little bit shorter. I'm going to use b to the power negative, wait, sorry. Okay, b to the power negative 2. I'm just going to save that part. And b to the power, so 5 to the power 0 is equals to 1. Okay, so that would be consistent with the column A. Column A. So these are the examples, and these are, of course, the formula we have recognized. The key point here, the fundamental reason that I don't want you to make this a burden to your memory is that I want you guys to learn to derive them. So all of these exercises here is to have you guys practice on them. You need to write them down, go through the steps so that you never have to memorize them. Okay, trust me, when you try to memorize these things, it can be very confusing. It can be very confusing if you don't understand what you're doing. Okay, so now with all of that we have done, so let's look at column B. Okay, column B, we have b raised to the power half multiply b raised to the power of the third. How do we handle that, right? You would use the same idea, the same formula. It's multiplication, right? So just like what we do with a to the power 5, multiply a to the power 3, and over here, we're going to be adding half and third. Adding half and third. Okay. And then the difference between adding half and third is just in the previous case, you do 3 plus 5 plus 3, and here you do half plus third, and you operate on the fraction. And then you just operate on the fraction. You're going to find the common denominator. Okay, you're going to find the common denominator. The common denominator, of course, is going to be 6. Right? 1/2 is 3 over 6. 1/3 is 2 over 6. And in the end, you get b raised to the power of 5 over 6. Could you guys do that, please? Right? So no difference whether your exponent is a fraction, decimal, anything you do in this circumstances, you just add the exponent. You just add the exponent. Okay. Third row, column B. Third row, column B. We have a raised to the power 6 divided by a raised to the power of -2. What do? We take the exponent, well, they have the same base. So we're going to keep the same base, and the exponents on top subtract the exponent in the bottom. So you have 6 minus the exponent in the bottom is a -2. So be very careful. Be very careful. So then you're going to have a raised to the power of 6 minus -2 is 6 plus 2. So in the end, you're going to get a raised to the power of 8. All right. So far, so good. Good morning, everyone. Okay. Multiplication. Okay. So in this scenario, we have b raised to the power of -6. And then the power is outside, it's -5. What do? Just like in this situation, so n could be negative, k could be negative, n could be positive, b could be negative. You know, in this scenario, you just do b raised to the power of -6 multiply -5. No need to memorize. No need to memorize because we have proved it, right? So in the end, we get b raised to the power of 30. So far, so good. So let's take a break. For the column B, I want you guys to column C on row 2, row 3, and row 2, row 3, row 4. Okay, just apply these 3 rules. Just apply these 3 rules. You ready? Okay, so here we have a raised to the power of third multiply a raised to the power of a quarter. Okay, so you guys please work on that. And the next one is quotient a raised to the power of half. And the denominator is a raised to the power of a third. Okay, so let me make it larger, 200%. Would that be helpful? Would that make it easier to read? And the third one is b raised to the power of 3/7. And then there's a parentheses. and raised to the power of 4/9. 4/9. Now, I want you guys to try these yourself. Please do. Okay, on your paper pencil with the examples on the screen, and you have written them down on your notes. So please try these. Oops. Common denominator, 12. Whoops. Yeah. So this is 3. So in the end, it's 8 raised to the power of 7/12. Okay, I'm going to move these expressions under to show you. Hopefully, it will show you better as how we write them down. Okay, by fitting them in the table, it's a little bit, you know, when you work these exercise after class, you don't have to do it this way. It's because the table is very crowded. Right? It's not a good idea. So I'm going to put them here this way. Okay. There. And for the earlier examples, wait, for this example, I'm going to put it here. It's a little bit crowded, right? It's a little bit crowded. So it's going to be like this, that, there. Hope this is clear. So what I want to show you, what I want you to emphasize is that, you know, when you write these expressions, make sure your half and third are not at the same level. Okay, they're not at the same level. If this is the level of B, you can see the exponent is above. It's a little bit above. There's a next level. And the level of equal sign is at the same level B, and this exponent is on the next level. It's on the shoulder. It's on the shoulder. Okay, so be very careful. Don't write it this way. Okay, so don't. Not this way. Don't write it this way. Okay, don't write B half, B third. Don't write it this way. Not this way. When you write it this way, it will be regarded not as exponent. It will be regarded as multiplication. Okay, you multiply B with half. You multiply B and multiply third. And it's different. So don't do it this way. Don't write it this way, okay? And the same thing is here. The same thing is said here for this exponents. Okay, in addition. Are we done? Are we done with this part? Okay, so I'm gonna wait for you. Take your time. Okay. So let's look at the next column. Wait. Oh, there. Sorry. Okay. Subtraction. Subtraction. Okay. A to the power half divided by a raised to the power third. Okay. How do we write it down? Okay. So let me just clean this up. Go down to that. Okay, so if you write it, you should write it this way. Okay, write it this way. And this obviously is the scenario of b raised to the power m or n, whatever. Doesn't matter, just the symbols, right? It's just symbols. Equals to b raised to the power of m minus n. Okay, or nk, right? Okay, so over here, you're going to have a raised to the power of 1/2 minus 1/3. Then you would work on the exponents. You keep the base, you work on the exponent, finding common denominators, which is 3/6 for half, minus 2/6 for 1/3. So in the end, you're going to get a raised to the power of 3/6 minus 2/6. So that's going to be 1/6. Okay, so when you write it down, be very careful. Be very careful. Okay, and this is the level of the base, and this is the level of exponent. They should not be at the same level. You should leave some space. Okay, you should leave some space here. Okay, you should leave some space here. You know, even the software doesn't leave in. It's not ideal. So let me write it down. Let me show you. Ideally, when you write it on paper, how would you write it? Okay, I would write a to the power half divided by a to the power for 1/3. Okay, and that's a raised to the power half minus 1/3. And keep going. A to the power of 3/6 minus 2/6. And last step, same denominator, 6 is kept, 3 minus 2 is 1. Okay, so if you do handwriting, you want to make sure they're all very well lined up, very well lined up. Okay, for example, this is on the same line, and these is on the next line. Okay, and this is on this line and the next line on the right top, the right shoulder. Same line, next line. You follow me? Okay, make sure you express yourself correctly. If you don't express yourself correctly, you will not be read as correctly the way you wished. Okay, so let's look at the column C, row number 4. Column C, row number 4. Okay, so I'm going to put this away. Okay, and over here, right, we can just put it over here as a raised to the power of 1/6. Okay, we've done that. Now, the next one is multiplication of exponents. Multiplication of exponents. right here. Okay, so the related formula would be e raised to the power of m, and raised to the power of n is equals to b raised to the power of m times n. Right, we have derived those. So in the case of, you have exponents that are fraction, no problem. You do the same thing. You do the same thing. So you have b raised to the power of 3/7 multiply the exponents of 4/9. Right here. Okay, they're at the same level. They're at the same level. And then it's b raised to the power of, you multiply these two exponents, right? So it's just like multiplying fractions, we can simplify, right? 3 and 9 can reduce. So 3 go into 9. That's left with 3. 3 times 7 is 21. 3 times 7 is 21. And 1 times 4 is a 4. That's it, right? So that's what you do for this question here. Okay, so in the end, we get b raised to the power of 4/21. All right, so we're done with the first row number 2, row number 3, row number 4. So let's look at the next one, the next row, B, column B. So when we have a power to a product, okay, so A times B, remember, this is A times B, not A plus B, okay? It doesn't work for A plus B, okay? So it's A times B. We derive the formula, we apply that to it. So next, we're going to see a little bit complication. We're going to see a little bit complication. So you have a to the power 4, b to the power 5, and then to the power of 3. What do we do with that? What do we do with that? Okay, so we're going to put, I'm going to set this aside. Right there. How do we deal with that? Right, so I copy this. And the property we can use is this one and more. So the first property we use is going to be that one, right? Well, you have power here, so you can treat this as like this. Okay, so let me just, so I just show you the symbolic. You don't have to show it explicitly. What you really see is that you have this to the power 3. And inside you have a heart multiply a spade. You follow me? So that's the heart and that's the spade. So when you have a heart times spade, right? So this is the heart and that's the spade. Okay? So we have this, you can totally do this symbolically. Okay, so the heart would be heart spade and n is 3. There. And of course, our heart is a to the power 4. And our, so this is a to the power 4. You want to put it in parentheses. And the spade is b to the power 5. Boom. Okay, b to the power 5. Okay, and of course, these two steps are repetitive, so we can just remove it. It just show you how to see it, how you see it. And next, we will get to apply what property? B raised to the power m, and then raised to the power of n equals to b raised to the power of m times n, right? So now we can get a raised to the power of 12, b raised to the power of 15. We're done. Okay, so that part, if you are to put it back, wait, here, right? That's going to be a raised to the power 12, b raised to the power 15. And the next one was division, with the division part, that's going to be a to the power 6, no, a to the power 6. Hold on. Something dropped. Okay, so it's a to the power 6 inside the parentheses, b to the power 4. And all of these together in the quotient, and then raised to the power of 5. Would you like to try this, you guys? You can still try the spade, right? Well, you don't have to. You don't have to. Okay. As a matter of fact, you can just go straight. Okay. So a to the power 5, a to the power 6, and get the power of 5 outside, b to the power 4, and then raised to the power 5 equals to. Okay, and this one is a to the power 30, and the denominator is b raised to the power 20. Okay, let's look at the negative exponents, right? We have a 2 raised to the power of -3. And that is going to be 1 over 2 to the power 3. And 2 to the power 3 is 8, right? That's 2 times 2 times 2, 3 times. Okay. On the next, on B column, is 1 plus e, 1 plus e to the power 0. Okay. This property tells us, okay, and of course we derived it, is that as long as b is not 0, if the b raised to 0 to the power 0 equals to 1. So all we have to do is to determine is 1 plus e equal to 0 or not equal to 0. Obviously, if e is 2.7, blah, 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 followed by many digits. So 1 plus e is not 0. So the answer is 1. Okay, I'm going to save column C for you. Okay, there are 4 other exercises for you. Let's look at the last 2 rows in basic 21. These 2 rows actually are supporting what do we have here? B to the power negative n. They're just elaborated it a little bit. They're just elaborated to it. Okay. And the first one, so it's A over B to the power of negative n. Okay, so these do not need to be the separate property, because this case is already covered by that case. Whether it's n or negative n, you handle them the same way. You handle them the same way. Okay, but we do want to see what happens in this case. Okay, we do want to see what happens in this case. Okay, so what is that? This is really another case for over here. Okay, so it's similar to this case. It's just one is negative n and the other one is n. N itself doesn't necessarily is positive or negative, right? We don't know. So you could handle it the same way. So instead of, so in this case, you're gonna have, to the power of negative n. Well, can you guys see the negative sign there? Can you see the negative sign there? Let me make it a little bit larger to see if you can see that well. Okay, 225%. Okay, so you see the negative sign. And what's interesting about this is that we can then apply the property. Apply which property? Apply the property of b raised to the power of negative n is going to be 1 over b to the power of n. Okay, sometimes, oops, sometimes, oh, come on, there. Sometimes you can see this process as such. Okay, denominator 1 is denominator 1. You don't have to write it. You don't have to write it. So these two are in this relationship. Okay, negative n and n are opposite to each other. So in this situation, so you would be having what? A to the power negative n will turn into what? A to the power negative n is going to be turned into a to the power n. Right? It was up here, now it's down here. And b to the power negative n, right? It was here, and now you move it to the positive x, you remove the exponents, you remove the negative sign in the exponent. So that's what it turned out to be. So a to the power negative n is going down, b to the power negative n in the bottom will go up. So in the end, what do we get? We get b over a raised to the power of n. So from here, the negative sign caused the inside fraction flipped. So that's the final answer. We want to put it in the table. The other side is a over b with negative n. Do you guys follow me? Do you follow me? Okay. It changed it. This expression is a little bit weird. Let's see if I can make it nicer. No difference. Okay, never mind. No big deal. Okay, so let's practice with a few of them. Let's practice with a few of them. On the row, second from last. Okay, second from last. Second from last. Okay, on column A. It's A over B to the power negative 1. Okay. So in this situation, there are a number of ways you can do it. There are a number of different ways we can do it. But one of the ways, if we use the properties similar to what we did, right? You will get A raised to the power of negative 1 and B raised to the power of negative 1. So we basically follow this rule. Okay, we just follow that rule. Okay. And as a result, in a lot of situations, we don't want to have a negative exponent. We want to turn them to positive. Okay, so how do we do that? So the A to the power negative 1 will go down. The B to the power negative 1 will go up. Do you guys follow me? Any questions? Do you guys follow me? These exercises can be very confusing if you don't follow. Okay, so it's better if you catch the place where you don't follow, you get stuck, and get it to me right away. Don't wait. Don't wait. Let me see if there's anything on chat. Any questions on chat? Is everything okay so far, you guys? Am I going too slow or too fast? Am I going too slow or too fast? Yeah? No comments. No comments. Are you guys there? Are you there? Ellen? Bree? Francisco? Marcelo? Are you guys there? Okay, good, good, good. Thank you for your response. Okay. So how about you try one? Could you try one? How about you try this one? Okay. So I'm going to give you some exercise to play with this. Okay. All you need is just practice, you guys. You can totally do it. If this is too boring or too easy for you, so please don't hesitate to tell me. Okay. So I want you guys to simplify this one. This one. Okay. Try this one. Okay. What you need to do, what we want to get rid of the negative exponent. So you will not have negative exponents in the end. Okay, I'm going to give you a couple minutes. Okay, so right now it's 11:14, and we should call it off at 11:16. You think that's a reasonable amount of time? Okay. If you're done earlier, if you are done earlier, okay, try the next one. Try the next one, which is a to the power 3, b to the power 2, and then to the power of negative 5. Okay, so for all of these two, I'm going to give you 5 minutes. How about that? 5 minutes. Try this. 5 minutes. This is not a test. Okay, just do the best you can. Just do the best you can. How's it going? So you might have figured out that the negative sign in the exponent is just flip the number from the bottom to top, top to bottom, right? Okay, so here you're gonna have equal. So 5 to the power -1. This is not the only way to do it, really. Okay, 3 to the power -1. And the negative sign just flip up and down. So you're gonna have 3/5. Sometimes, you know, sometimes sometimes people might do this. Okay, this person will treat this as b raised to the power -1. B raised to the power -1 is, of course, is 1/b, is 1/b. And the b here is the entire fraction, is the entire fraction. Okay, so it can be done this way, but if you're not very good at handling complex fraction, you may not want to do this. Okay, so the b is 5/3. Okay, so this is the b, right? So this is the b, right? And now b is a fraction. B is a fraction. And then you have to reduce this complex fraction. How do we reduce this complex fraction? We multiply by 1. And this 1 is going to turn into 3/3. 3/3 is 1. So to keep that equal sign, and that equals to, 1 times 3, that's a 3, right? 3/5 times 3, 3 and 3 reduce, that's a 5. So you get the same answer. You get the same answer, different ways, slightly different ways, really. And this is much easier to handle, in my opinion. If you don't mind to deal with the complex fractions, so go for it. Go for it. Okay. So now let's look at the next one. I assume you guys have finished. Okay, you guys have finished. So let's just compare notes. So we have a to the power 3 on the top. And then there's a -5 outside. And b squared. And then to the power of -5. Oops. Power. And there you go. Almost there. And the top is a raised to the power of -15. And the bottom is b raised to the power of -10. And flipping. Okay, you get b raised to the power of 10 over a raised to the power of 15. Okay. Any questions so far? Right, so these are the operations you could see from these exercises. And next, I wish to show you the last row. The last row is not anything new. It's just it's 1/b raised to the power of -n. What should that be? What should that be? Right? Well, it is indeed. It's actually b raised to the power of n. Okay, if you see better, it will be 1/. It's over 1. So it's really another way of of that. Okay, so these two are really the same thing. It's just, you just make sure that this is the opposite. Negative n is the opposite of n. So as long as these are opposites, right? This is b to the power of n. This n and that negative n, they're opposite. Okay, so let's look at some examples. So for example, 1 over b to the power negative 5. Now we don't want the negative exponent, so it's just going to be b to the power 5. Okay, and the next one, 1 over 3 to the power of negative 2. And that's just going to be 3 to the power 2, which is 9. Okay, and there's another one, which is 1 over 2 to the power negative 3. I'm going to leave that for you. So far, so good. Do you guys have any questions? Dealing with exponents, right? Dealing with exponents. So let's turn to basic, let's see, it's not, I think it's called alpha something. It's alpha 34A. So we did all of it alpha 34A except for a handful of in the column C. Okay, so after class, you should do all of them. Please. So next, we're gonna move to, if you want more exercise, you can do alpha 34B. But we're not going to do that in class, at least not for now. Let's look at alpha 35A. So now I'm going to reduce the fonts. Okay, so let's look at alpha 35A. Alpha 35A. This group of exercise is about the power of zero. One last row. You basically have 2 to the power 0, right? And this one is applying this property, b raised to the power 0 equals to 1. But this statement is conditional, provided that b is not 0. So you must check your base is not 0. If your base is 0, what happened? It's undefined. So 2 to the power 0, the base is not 1. The base is not 0, therefore it equals to 1. Right? And the second one, b raised to the power 0. Well, that equals to 1, but you have to make sure b is not 0. 4x. Okay, so in alpha 35A, we are told all variable bases are not 0. Okay, so we're given all variable bases are not 0. So that's reassuring. Okay, not 0. So this is b is not 0, therefore you can do that. And the next one, 4x, right? And the variable is not 0, therefore it equals to 1. Okay, so how about negative 3 to the power 0? Equals to 1, no problem. How about number 5 equals to 1? How about number 6? 0 to the power 0. Undefined. Okay, so I'm going to leave the rest for you. And of course, 35B is practicing the same thing. So let's fast forward. 36A. Okay, so let's do 36A. Let's do 36A. So in 36A, we're going to have a miscellaneous questions over there. Okay, so of course now we have all these nice properties we have learned. Right, we have learned all of these nice properties. Okay, I'm gonna bring them with us. I'm gonna bring them with us. Okay, all of these properties. We bring them with us. Okay, I may want them to line up horizontally, right? We'll have them line up horizontally. I want you guys to get started. And we're gonna take a break soon. Okay, so I'm going to make them horizontally. So I'm going to insert some columns. Okay, so I'm going to bring this guy over here. So that will just make it easier for us to browse on those properties when we need them. And I'm sure you probably don't really need them. Okay, probably don't really need them. But it's just at the beginning, we have some reference. Right, we have some reference for us. Okay, so this guy goes there. And that guy goes there. Oh, we have to get that formula over there. So there we go. We have one row. We have one big row. And of course, this one equals to okay, hold on. B over A to the power of n. It looks like we're gonna, one row is not enough, right? It's a little bit too small. Sometimes we don't see the negative sign. So I'm gonna make it better. So let's take a break, okay? Take a break for 10 minutes, come back at 11:40 and I will make it better. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm gonna do this. There. Okay, so 2 rows is they're gonna come with us all the time. I can even make them into one table. Right? There. Boom. Okay, one table. Okay, so come back at 11:40. Let's take a break. Okay, break time. Back at 11:40 a.m. I'll see you soon. Welcome back. All right, so let's practice with, so now suppose that we're pretty familiar with these properties. Be sure that you understand every property. And now we want to further understand this property and we are going to practice using these properties, okay? So that's alpha 36. Okay, alpha 36A. Okay, so let's start from the beginning. Okay, let's start from the beginning. We're gonna do the first 3 rows. The first 3 rows. Okay. And are you guys ready to take the lead? The first 3 rows. Okay, I'm gonna put it in the table. It seems to be a little bit easier for us to handle this, okay? So b to the power -3 and a raised to the power -5. These are directly using these properties. 3 to the power -2. In the result, we don't want to have negative exponents anymore. So we want to get rid of the negative exponents. Okay, so a to the power 4 multiply a to the power of a negative 10. And this one is 1 over a to the power negative 5. Okay, we have 3 rows we're going to work on. Let me make the fonts a little bit larger so you can see all the negative signs. And 5 times x raised to the power of negative 3, 6 times y raised to the power negative 4, and negative 3 a raised to the power of negative 5. Okay, so we have 9 questions. I would like you guys to take the lead. Take the lead, please. I think you can do the first row, no problem. Even the second row. Without not much of issue, I anticipate the last row, you may have some difficulty. Okay, but I'm here to help. I'm here to help. Okay, let's see. The formula sheet, I think I'll be better off if I do this. Okay, so I'm gonna make one more row. Okay, 1, 2, 3. This making to the third row. And this guy putting here. And these two we'll put in here. I think this is more better. This is better. So all of the formula, when I make the fonts larger, they're also available instead of going off the chart. So here's the question we're working with. You done? Okay, so let's compare notes. So the first one should be 1 over b to the power 3. So we're using that directly. Okay, and this one, same. 1 over a to the power 5, almost the same. This guy is 1 over 3 squared. And that's going to be 1 over 9, 1/9. That one is 1/5. Over here, you're going to have a raised to the power of, there are 2 different ways to do it at least, okay? You're going to do 4 plus negative 10, if you wish to do it this way. And that's going to give you a raised to the power of negative 6. Getting rid of the negative sign, so you're going to, the negative sign in exponents, you're going to get 1 over a to the power 6. And the next one, of course, is going to be a to the power 5. So far, so good? So far, so good? Any questions? Now, the last row can be a problem. Not the last row can be a problem. Okay, so I'm going to put a new row to put the notes in. Okay. Sometimes some of our students get confused when they do the exponents and they will do this. That is wrong. Okay, that is wrong. Okay, that is wrong. All right, the negative exponents only apply to the base of x. It doesn't include the 5. It doesn't include the 5. So the right answer should be 5 over x raised to the power 3. Do you get it? Do you follow? Okay, so this will be wrong. Okay, the 5 doesn't go to the denominator. It stays on the top. So basically, you should view this as such. Okay, you should view this as such. They're separated. Okay, they're separated. And the next one, same thing. Okay, it's going to be 6 over y to the power 4. Okay, last one. The last one, we saw all kinds of mistakes. We saw all kinds of mistakes. Some people will take the negative sign on this in the exponent combined with this negative sign, they turn into positive. No, please don't do that. Okay, they're not at the same level. They're not at the same level. They cannot combine. They're not at the same level. So please don't do it. So what you do, the answer in this case, okay, the power is for the base of A. The base does not include the negative 3. Okay, it's separated. So you should view this as separated. Okay, you should view this as separated. And A raised to the power negative 5 is going to turn into what? 1 over A to the power 5. So in the end, it's just a negative 3 over A to the power 5. This will be a way that we write a commonly to express this expression without the negative exponent. So far so good? So far so good? Okay, so be very careful. Okay, be very careful. Okay, so the 6 doesn't go under. So let me point out the wrongs in here. This will be wrong. Okay, that's wrong. Okay, and over here, there are all kinds of wrongs. One of the wrongs is that people will turn this into, I don't know, I forgot exactly the mistake. But this is certainly, right? Don't do this. Don't do this. Okay. The negative sign can be in the front. It's all wrong. It's all wrong. Okay, so these are the wrongs. Okay, did you write it down? So let's look at the second 3 rows. Okay, let's look at the second 3 rows. So that's going to be row number 4, 5, 6. 4, 5, 6. Runs from number 10 to number 18. Number 10 to number 18. I don't think we need to do all of them in class. Okay, so I want you guys to choose 3 out of them. Okay, so please choose 3 questions out of number 10 through 18. Okay, so I'm going to have the table ready to answer your questions. I'm going to give you 5 minutes. 5 minutes. So these are number 10, 11, 12, So 7 times 3 to the power of -2, a to the power 3, a to the power -5, 1 over a, whoops, 1 over a to the power -2. 1 over c to the power -4, b to the power 5, b to the power -8. That shouldn't be any problem. Over here, 1 over 2 times b raised to the power of -5. That could be a problem. The last row, 16, 17, 18, I don't anticipate any problem. But if you have any issues, don't hesitate. Don't hesitate to let me know. So 5 raised to the power -1. Okay. So we will come back to this. I'm going to give you a couple minutes. Take your time, please. How's it going? Okay, the first one, don't combine 7 times 3. Okay, we should do exponents first. Remember, order of operation. So this one should be equals to 7/9. Okay, and I don't think you have issues with these. And that one should be, okay, b to the power -5 will flip up. Okay, so you're gonna have b raised to the power 5 on the top. But there's a 2. The 2 doesn't go with it. So 2 stays under. Okay, 2 stays under. Got it? What's wrong with that? What did I do here? Oh, you know what? I made a mistake. Okay, the typesetting is not right. Should be b raised to the power 5 over 2. How about that? This is better. Okay, I don't anticipate any issues here. I think we've done them. Any questions? Okay, so we did up to 18. So 2 more rows. Is there any question you wish me to do it just to make sure? No? The last 2 rows. Okay, the last 2 rows from number 19 through number 24. I don't anticipate any question unless you have one. Please don't hesitate to let me know. The one that I thought might have some issues is a raised to the power of -12. Okay, this would be, equals to 1 over a raised to the power of half. And 1 over a raised to the power half. This is really just basically square root of a. Okay, so that's the notation. That's the notation. Basically, the exponents. Okay, the exponents here, the power, the 1 goes to here. Oh, sorry, 1. The 2 goes here, √2, right? √2. So let me write another way. So this is √2, and this is a. Wait, sorry. Let me do it over, okay? So this is √2. So this 2 in the exponents, right? The denominator in the exponents goes to the root. And a raised to the numerator here raised to the power of 1. And of course, by default, we understand when we have a square root, we don't have to specifically write that 2 there. So a to the power 1 can be written as a alone. Okay, so that's the process. So that's the only question. I think there might be some issues. Do you have any questions? No? Yes? If you want more exercise, feel free to do it 36B. Okay, any question, anytime? And you should anticipate another quiz today. If not today, tomorrow, you will have another quiz. You're gonna have 2 quizzes this week. And next, we're gonna move on to Alpha 37. Alpha 37. Alpha 37 are exercise I got from a pre-algebra textbook, okay, by Mr. Tussey, okay, the same author that wrote our current intermediate algebra textbook, and he also wrote the textbook for pre-algebra. So he gives a group of exercise. I thought they're rather good. They're rather good. Okay, so we're going to study these comparatively, okay, along with our beautiful properties here. Okay, along with our beautiful properties here. You can see all of our properties here. They are either multiplication or division. Okay, multiplication or division. No adding, subtracting, except, there's some adding, subtracting in the exponents, right? So in fact, we don't have these properties such as, okay, for example, if you say, oh, if this is true, right? How about we add them? There's no formula for it. Okay, then how about subtracting them? No, nothing. So adding, we have nothing. We have no formula for it. Subtracting, we have nothing for it. But what if we encounter those problems? Okay, so let's look at this column, let me put just one row. Okay, we have this 2 to the power negative 1 plus 3 to the power negative 1, and then to the power of a negative 1. Ooh, that's a lot of negative sign, right? And the other one is multiplication. Okay, so let me just keep it simple. There. That's question number 1. That's question number 2. Question number 1, question number 2. You look at these properties, right? Look at these properties we're familiar with. Which one, the first one, second one, which one can we apply the property? For which one of these two? Number 1, number 2. For which one can we apply the property to? Let's have a vote. To which one can we apply the properties? What do you think? Not number 1, right? Not number 1 for sure. Because number 1, you have those exponents, but it's adding. You don't have those, adding, subtracting when base and exponents considered, right? You cannot add, you cannot do any one of these properties. So for the first one, you cannot apply any one of these properties except this one, okay? And that one, we can apply this property. Do you follow me? Okay, so now what do we do? For number 1, what we can do is to keep that. We cannot apply the power like we do here or here. We cannot. So what we can do is that we turn those into 1/2, and we turn this into 1/3, where we apply this rule, okay? Where we apply that rule. So I'm going to point it out that. Okay, so 2 to the power of a negative 1 is 1/2 to the power of 1. Okay, 2 to the power negative 2, 3 to the power of a negative 1 is 1/3. All right, so that's the only thing we can apply here. Okay, we cannot apply the power inside here. We cannot. And then what do we do? Then what else can we do? We're going to combine, we're going to operate inside the parentheses. Okay, the negative exponents stay outside waiting. Common denominator, 3/6. Common denominator of, found, so 2/6. And now we're almost there. We're gonna still working on in the parentheses. That's gonna give us 5/6. Now we can apply those other properties we learned. Okay, in particular, this one would be most useful. You don't have to do that, just apply, this easiest way possible. There's so many ways to do it, right? So here you can do 5⁻⁻1, where now you're applying this property, right? We're applying this property if you wish. Okay, so I'm going to put it over here for your reference. Just understand this, the way I do it is not the only way to do it. Okay, so this is -1. So this is going to be -1, and this is going to be -1. Right? And A is 5, B is 6. So 6 raised to the power -1. One more step. Okay. 5 to the power -1 goes under, and 6 to the power -1 goes up. Done. Okay, where we have just applied which property? This one, these two, right? These two. We apply these two properties. Okay, so the whole question, so you can see we cannot apply immediately, but we apply to some of the properties individually. Okay, in some minor steps, Did you guys write it down? So please take your time to think about these steps. Do you want to try it yourself? Do you want to try it yourself? How about we do this? Okay, I'm going to stop the share for 2 minutes. Okay, you're going to redo the whole thing. Okay? Number one, okay? Number 1, 2 minutes. 1, 2, 3, set, go. All right, how's it going? You got it? Oh, I lost someone. All right. Okay, so let's look at number 2. Did you get it? Now let's look at number 2. Number 2. Number 2, we can actually do it by applying the properties, Okay, so which property do you think applies? I think this is the property would apply. Okay, this is the property that would apply. So our A is 2 to the power negative 1. B is 3 to the power negative 1. So we can apply the power just like what we do here. So this is going to give us the 2 to the power negative 1 that was in there. That was the A. And then there's another power outside, and 3 to the power negative 1. And then there's a power outside. Okay. And then we can apply this other property over here. There. Excuse me, right there. Okay. So this is the B, right? B, N is negative 1. K is negative 1. So we're going to multiply these two exponents, which will give us the 2 raised to the power of negative 1, right? Times negative 1. And 3, same thing, negative 1 times negative 1. And in the end, we're getting 2 times 3, which is 6. Okay. But I do want to mention there's another way to do it. Okay, if you don't apply these rules directly, you could do the following. Okay, so I'm putting it on the or. Okay, so what you could do is that you can put this equal sign here, right? And what you do inside, you're gonna have half. This is half, right? And this is gonna be a third. And you're gonna take care of the parentheses. Inside the parentheses, right? The power stays outside waiting. And 1/2 plus 1/3 is 1/6. And then you're going to apply the negative sign, negative 1 exponent to 1 to the power negative 1 and 6 raised to the power 6 raised to the power negative 1, right? And in the end, you still get 6. Sorry, still get 6. You still get 6. 1 to the power negative 1 is still 1, right? That's 1. and the 6 to the power negative 1 flip up. Okay, so these are the two these are the two exercises that I think is quite representative, and I hope it resolves a lot of confusions. Okay, so next I wish you guys to work on, okay, this time you're going to do 3, 4 completely. Okay, please try 3 and 4. Similar questions. Please try 3 and 4. Okay, try 3 and 4. Let's see, I think I can give you 5 minutes. Okay, if you're done with 3, 4, maybe try some more. But you know, once you get the hang of it, you can do the rest. I'm gonna give you 5 minutes. 5 minutes, either way. Let's see if I can make it a little smaller. Let me do this. Hold on. Insert row. Insert a column. Put this over here because this is a little bit too spacious. Okay. See if 175% will do. Okay, so this is better. So you can see these two different ways as you work on as you're working on number 3 and 4. Okay, so please try number 3 and 4. Please try 3 and number 4. Take your time, okay? I will fix up a quiz, one more quiz for this week. Okay, it should be available either today or tomorrow. Try them. It only gets easier. Okay, guys. How was that? How did it go? How did it go? Good? Any questions? Are we good? So for number 3, right? I would say if I change these questions to number 3 and number 4, right? This changed to 3, and that is changed to 5, and 3, 5, right? That was the question, right? So question number 3, question number 4. Okay, so how can that be done? Well, it's going to be very similar. It's going to be very similar. So number 3, we're going to work the steps. I assume you guys have finished, right? So all of these steps we've done earlier, right? There's some similar steps there, over there. Okay, so just forgive me, I'm going to be a little bit lazy, but I want to show you the similarity. Okay, so now the common denominator is 15. And of course, this is 5. And this is 15, and that is 3. So the denominator is a 15, and that's 8, right? And this is 8, and that's 15. And in the end, you get 15 over 8. All the reasons are similar. All the reasons are similar. So here's 3 to the power negative 1, is 1 over 3. 5 to the power negative 1 is 1 over 5. There. For number 4, similar. Okay, for number 4, similar. Right? Completely similar. You can use any way you want. Any way you want. And if you use the way that we did earlier, which I think this is much easier, much shorter sometimes, okay? And so here we go, right? So we're having that one. So this guy is gonna go here. That reason is going to go here. And that reason is going to go here. Right? So it basically the same steps. Clear all drawings. Okay, the only difference here is going to be, this is going to be 3, and that's going to be 5. So this is 3, and that is 5, and that is 3, and that is 5. Has it become easier? You probably feel that way too, right? If you go down the list of 37A, and sometimes there are different numbers, you can see the exponents getting gradually different, and the ideas are very similar. So I'm going to leave these for you. Is there any one that you want me to do for you, just in case? Anyone? Anyone? Everybody? No? Yes? Don't be too polite. I'm here to help. I'm here to help. Okay, so 37B. Okay, if you want more exercise, there's some more exercises right there. Okay. The next part, we're gonna get into the next part of our plan for this semester is factoring. It's actually factoring. But before we do factoring, we're gonna do the reverse of factoring. We're gonna do the reversal of factoring. Okay, factoring is certainly a big topic. Okay, big topics. So let's look at alpha 38. Okay, X, it's not factoring. This is about multiply. Multiply. Okay, multiply. Multiply. Okay, so before we do factoring, we're going to do multiply. So this is the opposite of factoring. This is factoring. Have you guys heard of FOIL? Have you heard FOIL? Have you guys heard of FOIL? You probably have. Even if you don't know this word, it's no big deal. Okay, I didn't learn, by FOIL. I don't know how I learned it, but it's just something you know how to do, right? We've done something similar before. And for which I wish to bring back the scenario. I think this is fine. Okay, it's FOIL. So take the first, for example. Okay, the easiest one out there. Okay, so x plus 3, x plus 2, right? We have actually done similar things in the section of quadratic, right? So some of these are quadratic, and of course some of these are non-quadratic. Okay, so we're gonna do factoring eventually after alpha 38 in general for quadratic and non-quadratic. But so let's revisit the idea about FOIL. Okay, so let's revisit this idea about FOIL. What is a FOIL? Okay, what is a FOIL? FOIL basically is a process that you can see this, right? I don't imagine there's any problem for FOIL. So I'm going to just go straight to it. Okay. So you're going to take the first with the first, because here this is the parentheses. You have a first, second, a first, last, a first, last. So first, the first F is for first time the first. So that's going to be X times X. Okay. Oh. Okay. Outside. So the first and the last of the second one. So they are both outside, right? X is outside, 2 is outside. So X times 2. That's the O. And I is the inside. 3 is inside, X is inside. So 3 times X. And L is for last. Last times last. So 3 times 2. Okay. You usually don't need to show this step. You don't need to show this step. But what you have, what you need to do, the next one you need to show, which is X times X, of course, is X squared. 2X plus 3X, right? There's a 2 times X and there's a 3 times X. That's going to make a 5X. And the last one is 6. Okay, so this is the FOIL. Does everybody know how to do the FOIL? No problem? No problem? Okay, so could you do them all if I leave them for you? I'm sure you can, right? So I'm gonna save alpha 38 all for you to practice. Okay. Along in that table, you see that there's some perfect square there. There's some perfect square there. Okay, there's some perfect squares which we have done. Okay, and so we have done. So next we're gonna move on to alpha 39. Yay, alpha 39 factor, the opposite of expanding. Okay, so alpha 39 factor. Oops, TOR. Okay, factor. Factor is the opposite. Factor is the opposite of FOIL. Okay, so why do we want to factor? Why factoring? Okay, why factoring? Have you thought about why you have to do factoring? You have not. You know, it's a topics that you have learned since elementary algebra, if not sooner. I believe that you have done this in pre-algebra, right? Factoring. But in those cases, you were doing like 6 = 2 times 3, that kind of factoring. But in elementary algebra, you're doing factoring. You're doing factoring for a long time. So then you say, why factoring? Why factoring? Right? That's a good question, isn't it? That same question when I was I was a student for so many years, and now I was teaching for so many years, and I was thinking, why do we do factoring? Our students just have hard time sometimes to factor because they are polynomials or expressions, which is a little bit difficult to factor, right? But why factoring? So now I want to give you a perspective. From the perspective of mathematical principles, okay, we have 6 mathematical principles, right? We have 6 mathematical principles. If you look at those 6 mathematical principles, you will see some of those. To apply some of those principles, you need to have factors. For example, number 5. Number 5, right? Math principle number 5 is a typical reason for factoring. What is it? Is A times B equals 0, right? If and only if A is 0 or B is 0, right? We need factoring. We need factors. We need factors, right? A is a factor, B is a factor. What else principle we need? Math principle number 6. We also need factoring. Okay, we also need factoring. We also need factoring. Recall what we did for alpha 32, isn't it? Alpha 32, right? When we solve inequalities, right? We want a greater than or equal to 0. So in recall alpha 32a. Okay, alpha 32a, am I right? Am I right about that number? Alpha 32a. Yeah, I think I'm right. Alpha 32a, right? Those are product, those are quotient, and they're all in those form of what? Right? All those if statement, right? If you look at those if statement, of course, one of the method we use, right? One of the method we use, the sign method, right? We often deal with like if what? If A times B is greater than 0, if A times B is greater than 0, right? Or if A times B is less than 0, equal to 0 is handled by principle number 5, etc. Okay, or in other situations, such as if A divided by B that's a factored form as well. Okay, that's a factored form as well. Okay, and in some other situations, if A divided by B is less than 0. Okay, so why factoring? Because when we apply principle number 5, principle number 6, these if statement involves factoring. We need factors. We need A times B. We need A times B. We need A divided by B, and so on and so forth. So look closer to the 6 principles. What else principle do we need factoring? Factors. 5 and 6 are the primary one. 5 and 6 are the primary one. You can say number 4 also needs factorings. Okay, that's a form of factoring, but oftentimes it's not that direct. Number 1, anything times 1 stay the same. That one involves factors as well. Okay, especially in the case of finding common denominators. So 6 principles, 4 of them needs factors. Okay, 6 principles, 4 of them needs factors. So this is a big reason, isn't it? This is a very, very big reason. So why factorings, right? So primarily because of principle number 5, number 6, and you can also say loosely say principle, math principle number 1, number 4. Okay, in those cases, we need factors as well from time to time. Okay, but it's not in such a direct form as the way we did number 5 and 6 on the if statement, but those are, those are also situations that we need factored form. Okay, so this is the why factoring. The next question is how. Right, how? Right, so we have the why. And now how to factor. how to factor. How to factor is a big topic. It's a very big topic. Okay. In fact, it could take half the textbook of any elementary textbook, any elementary algebra textbook. Okay, any elementary algebra textbook. How to? Okay, and I'm sure you guys have all learned some ways to factoring, okay, in your past experience. Okay, there's so many ways to do it, but all these different ways of doing it, it involves the greatest common factor and factoring the trinomials. So we're going to do some basic techniques once. One of the basic techniques, right? For example, how to factor, right? So suppose you have two terms. Suppose we have two terms. Case one, right? Just two terms. Why don't we consider one term? Well, one term is already factored, right? We don't need to do anything about it. So suppose we have a 5x to the power 3 minus a 17 or maybe 20, right? X raised to the power of 2. That factoring is easy. That factoring is easy, right? Everybody can do that. Say 5 is a common factor between 5 and 20, so 5 is out. And x squared is a common factor. And then we do the factoring, right? So that's become x minus what? Done, finished, right? And there's two terms. The second case is a big category. It's a big category. The second case is a big category, right? You can have 3 terms of anything and find common factors, find the greatest common factors. One of the simple cases, one of the cases with 3 terms, factoring is the quadratic form. It's a quadratic form. It's this form: ax squared plus bx equals c. This is a big category. This is one of the big category. Of course, you can have 3 terms. They don't have to be in this form. But this form is considered one of those basic factoring forms. Okay, for reasons for of course, the important reason is because of fundamental theorem of algebra. Okay, of course, you might not have learned that fundamental theorem of algebra, but that's okay. So we're gonna start from here because this category is very much the focus. I would say it's very much of an academic focus. So it's not, however, it is not only academic. It is also for practical reasons. It's also for practical reasons. Okay, so a lot of the method we have studied is about factoring this form. It's factoring this form. Okay, it's called a trinomial. Have you heard of that word? Trinomial. Trinomial. Okay. In most of the textbook, okay, they are usually like at least one chapter. Usually it's about one chapter is dedicated, or 3/4 of a chapter is dedicated to factoring trinomial. Are there a case 3, case 4? Of course. There are case 3, there are case 4, etc. Okay, but we're going to focus on this factoring trinomials. Okay, so we're going to focus on trinomials because when we have 2 terms, it's pretty straightforward. When we have trinomials, however, that is the, that's a little tricky. Okay, so to factor this trinomial, okay, so we're going to focus on factor trinomial because this one is It's very basic. It's very basic. So we're going to start from here. So you can see alpha 39 is very much focused on factoring these trinomials. Three terms. Okay, and the reasons are fundamental theorem of algebra. And so we're going to start from a couple cases, right? One case of factoring trinomials is when a is equals to 1. A equals to 1 is one case. Okay, and the other case is a is not equals to 1. Oh, a is not equals to 1. So what I'm going to have two cases on factoring trinomials, just like the textbook has classified. Factoring trinomials, we have case 1 and case 2. However, I want to declare that factoring trinomials, even though we talk about this method, it doesn't guarantee you can factor every trinomial easily. Theory guarantee we can factor every trinomial, but it doesn't guarantee we factor them easily. Does that make sense? So one thing is certain, we can always factor trinomial. There's a theorem guarantee that, but it doesn't guarantee it can be factored easily. So how easy? So we have theory to guarantee that. That's what I want to say. And secondly, it's not easy, or I can say it's not always easy. So we're going to start from the beginning of factoring the case with a simpler case of factoring trinomial. Okay, case 1, a is equals to 1. This is one case. This is one case. Okay, and of course, the second case, we're going to factor a is not equals to 1 arbitrarily. Of course, case 2 include case 1, but case 1 is easier. So we start with case 1. Does that make sense? So today we have 8 minutes left. I just want to give you a head start. I know you guys have been taught many different ways of factoring by your previous teachers. One thing is certain, all of these different techniques, they actually are derived from one source, okay? They derive from one source, and I will review to you that one source. But before we do that, I'm going to start with some technique. Okay? So the technique I'm going to show you, okay, is the following. Okay? So take the example, okay? I think we can better explain this with an example, right? X squared plus 5x plus 6, right? This is something we already know. We already know the factor, right? So I'm going to use this example to illustrate this technique we use. Okay? So we have x squared plus 5x, right? And for x squared, the coefficient, of course, we know is 1, right? And the constant term is 6. Okay, the constant term is 6. So with that recognized, we know that 1 is equals to 1 times 1. So I'm going to set up in a way that this 1 is equals to 1 times 1. Okay, 1 times 1. So this means 1 times 1. Okay, so just you don't need that sign there. 6 is equals to 2 times 3. Okay, so you just multiply those two numbers. Okay, so this is the basic setup. It's like you're playing a game and there's a basic setup. Okay, and then we're going to do the following operation. So these two dots we can remove. What are we going to do next is that we are going to do the cross multiplication. Okay, 1 times 2. 1 times 2 is going to give us, okay, so let me do it this way, okay? We add a column, and this cross product, okay, 1 times 2, okay, so let me, if you can see if I can insert a arrow, right? So 1 times 2. 1 times 2 is going to give us 2. Column. So 1 times 2 is 2. Okay. 1 times 3 is 3. Right? 1 times 3 is 3. You guys follow me? I would put an arrow here, but I don't think I can. Yeah, I don't think I can here. Okay, so it can only put one symbol there. Yeah, so we don't have so many symbols, but I'm just going to use the tool that we have here. So this is going to be that. Okay, so 1 times 2 is 2. 1 times 3 is 3. Next, I'm going to have another row. I'm going to have another row. This other row is going to be adding these two numbers. Adding these two numbers. When we add these two numbers, we have 2 plus 3, that's equals to 5. The goal of this game is to match the 5. Positive 5, okay, along with the sign. So we have a perfect match. 5 matches the positive 5 right here. Okay, so you see the setup. And next, if we have made such a perfect match, okay, we have found our factors. We have found our factors. Wait, that's the wrong place. Okay. Delete that. Home column. Okay, we have found our factors. We have found our 2 factors. Okay, so what are these 2 factors? These 2 factors are from the first row, okay, from the first row, so let me, from the first row, so bring them together. From the first row, oh, this arrow is in the wrong place. Okay, so I'm just going to get rid of them. Okay, we don't need that. Okay. From the first row is x, this is 1, 2, the first row, right? And we set it up this way, we made the perfect match. So the first row, we're going to take the 1, and we're going to multiply the x, and we add the 2. The second, this row, the third row, is we're going to take the 1 times x plus 3. And we got our factors. We have got our factors. Okay, so this is the setup for, and you can easily do this on your paper. Okay, so I'm going to write a handwriting version of this process. I'm gonna write a handwriting version of this process. Okay, so right here. Okay, so this is something set up. I want to keep it organized in my classes. Okay, we'll see if that works. Okay, the handwriting version of this is the following. Okay, you can write it. Okay, so the 1 is equals to 1 times 1. Okay, the 6 is equals to 2 times 3. and we cross multiply, hold on. We cross multiply. We cross multiply. And 1 times 2, 1 times 3. Okay, so we're gonna get 2 from 1 times 2, 3, 1 times 3. And then we add the 2 and 3, we get 5. Okay, and does the 5 matches the 5 over here? It does. Positive 5, positive 5. We want that perfect match. Once that perfect match is made, we got our factors. We got our factors. We got 2 factors from each row, 2 rows. Okay, the first factor would be, we take the 1 times x plus 2, because that's a positive 2, right? The second row, 1 times x plus 3. So in the end, we get 2 factors, and they are x plus 2, x plus 3. Okay, guys, which way do you prefer? Do you prefer the handwriting way, or you prefer the table way? I'm trying to get it organized in such a way, because no textbook taught it this way. This is how I was taught. Okay, so I've been because I found this way is much easier for me. It's not I'm not open to any other ways, but I really have practiced this way teaching my classes. And a lot of my students actually like it. I haven't found any textbook this way in the US. Okay, this is how I was taught. Okay, so which way do you prefer? Right? It doesn't really matter, because when you do this, you're going to be working on your paper pencil. So it's a handwriting. It's a way of handwriting. Okay, so you're making that perfect match. So this is the setup. So the final answer for this, of course, we already know the answer. Okay, we have x plus 2 here. X plus 2 times x plus 3. Okay, so we're going to end here today, and we will continue doing this on Monday. Okay. I'm not asking you guys to, get rid of the method you have learned before. If you have another method to factor and set up, whatever you do, it works for you. I'm not asking you to abandon it, but I need to have a consistent way of demonstrating how to factor in this class. So this is the way of my choice. And I'm totally ready to learn your way if you can explain it to me. And because regarding this topic, there's so many different ways, Okay, so I will see you guys on Monday. So do we expect another quiz? Okay, I will see you guys on Monday.